Hi everyone. Today I will talk about an example of absolute convergence versus conditional convergence. So before we begin, let's just recall the some main theorems about alternating series and the definitions of conditional convergence and absolute convergence. So first of all, this is theorem 5.13 from the textbook, which says that an alternating series of the form -1 to the n plus 1 is the sum from n is equal to 1 to infinity of -1 to the n plus 1 times bn converges if 0 is less than or equal to bn plus 1, which in turn is less than or equal to bn. So this means that the bn's are decreasing. And the limit as n goes to infinity of bn is equal to 0. All right. So this is the alternating series test. Now let's define absolute convergence. So a series, the sum from n is equal to 1 to infinity of an, exhibits absolute convergence if the sum of the absolute values converges. So if the sum from n is equal to 1 to infinity of the absolute value of an converges. In contrast, a series, the sum from n is equal to 1 to infinity of an exhibits conditional convergence if the sum of the absolute values diverges. So again, this is in contrast with the absolute convergence. So again, a series converges conditionally if the sum from n is equal to 1 to infinity of the absolute value of an diverges, even though the sum n is equal to 1 for infinity of an converges. As you can see, I made a grammar mistake over here, so I had to correct it with my pen. All right, so now let's go through an example from the textbook. This is exercise 521, I think. So, all right, this says for each of the following series determine whether they diverge, converge conditionally, or converge absolutely. So the first series we're going to talk about is the sum from n is equal to 1 to infinity of -1 to the n plus 1 of times 1 over 3n plus 1. All right, so let's see whether this converges. So in our definition, you can see that the -1 to the n plus 1 is the same as in our theorem. And we can take our bn's. So let's prove. Let bn be equal to 1 over 3n plus 1. Okay. So let's check our condition. First of all, we want the bn's to be positive and decreasing. So obviously, 0 is less than or equal to 1 over 3n plus 1, 3 times n plus 1 plus 1, which is just equal to 1 over 3n plus 4. This is our bn plus 1. And this is going to be less than or equal to 1 over 3n plus 1, which is our bn. So this means, well, that our first condition in the theorem is actually met. Now, we also need to prove that we want the limit as n goes to infinity of bn to actually go to 0. Well, but this is equivalent to showing that the limit as n goes to infinity of 1 over 3n plus 1 is equal to 0. But this is very easy. We all know this from Calc 1. So therefore, both the conditions in theorem 5.13 are met. So because of that, by theorem 5.13, we know that the series sum from n is equal to 1 to infinity of -1 to the n plus 1 times 1 over 3n plus 1 converges Now let's see whether this converges absolutely or conditionally. I claim that it converges conditionally. So we know that the sum converges, and we want to show. So in order to show that it converges conditionally, we want to show that, well, the sum on a different line. Sum from n is equal to 1 to infinity of the absolute values. So absolute value of -1 to the n plus 1 times 1 over 3n plus 1 diverges. Well, with the absolute value of -1 to the something to n plus 1 is just going to be equal to 1, right? So the absolute value of -1 to the n plus 1 times 1 over 3n plus 1 is just 1 over 3n plus 1. So want to show, or need to show, that the sum from n is equal to 1 to infinity 1 over 3n plus 1 diverges. So how can we do this? Well, some sort of motivation for this would be that, well, 1 over 3n plus 1 is approximately the same as 1/3 of 1 over n, right? And well, we know that, so therefore, I guess the sum from n is equal to 1 to infinity of 1 over 3n plus 1 is going to be approximately 1/3 of the harmonics here. And well, we know that this diverges to infinity. So this is also going to go there. But this is math, so we have to rigorously prove stuff. So we can do this by the comparison test, again, with the same harmonic series. So we know that the limit then goes to infinity. So 1 over 1 over 3n plus 1 over 1 over 3n, 1 over n is, this is just equal to n, to the limit as n goes to infinity of n over 3n plus 1. And this is just equal to 1/3. And obviously this is just strictly greater than 0. So by the comparison test, we know that this series is going to diverge, which is exactly what we want. So this is part A of exercise 5.21 from the textbook. And I hope you've enjoyed it.